Hello students, in this video I will be talking about a topic called as P, NP and NP complete problem with relevant examples. Okay, so this comes under the subject analysis and design of algorithms and subject code is PCS 401. This is coming under the second topic of fifth module for this particular subject. So first is about the algorithm. What is an algorithm? See, the definition is it is a set of well-defined instructions in sequence to perform a particular task and achieve the desired output. Okay, so we have a problem statement and we analyze the problem statement and we get to know that this problem statement gets the solution by following certain steps. So that following set of steps are returned as a set of instructions and this together is called as an algorithm. See, suppose I have an algorithm. Okay, see, if I have a problem statement and I have the result, okay, output. I have the result. So in order to get this result, I have to follow this set of instructions. So I will call that set of instructions as algorithm. Now the thing is, when you're writing an algorithm, there are two types of algorithm. See here, on the basis of the knowledge about the outcome of the instructions, there are two types of algorithms, namely deterministic algorithms and non-deterministic algorithms. When you're writing an algorithm, your intention is to get the desired output. Okay. So sometimes what happens is based on the output, the type of output that you get out of the algorithm is divided into two types, that is deterministic and non-deterministic. See here, when you have an algorithm, let's say adding the two numbers. Okay. So if I give the numbers as 2 and 3, okay, I am sure that the answer is going to come as 5. 2 and 3. The answer will come as 5. Next time, if I run the code again, okay, so I have written the code, I have run the code for 2 and 3. After a few months, if I run the code, again, I will be getting the same result. So if I give the input as 2 and 3, I will get the result as 5 itself, no matter how many times I run the code. So for a given set of inputs, okay, for the same set of inputs, if I run the code multiple times, okay, the algorithm will give me the same result. So such type of algorithms are called as deterministic algorithms. Okay, I will first remove all the information that is not required. See here, it's a type of algorithm in which the result of the algorithm is uniquely defined. The input is there, and if you give the input, it will give you the same output. See, deterministic algorithm can solve a problem in polynomial time. It always has a single outcome. That is, the output, it gives always the same result for the same in the same output. That is, if I have the problem like, for example, multiplication. If I have an algorithm for multiplication and if I give the same set of inputs, it will give me the same set of outputs no matter how many times I run. So the output is clearly defined in case of deterministic algorithm. Now you have, see the examples I've given adding the two numbers. So 3 and 4 will result in 7 always. So 3 and 4 will always give me the answer as 7 no matter how many times I run the code. Similarly, one more example. This will make you relate how the real life example can be added for this. So we have ATM withdrawal. Okay. So it always follows a fixed number of sequences. See here, you check the balance, then you deduct the amount, then dispense the cash, and no, in this case, there is no randomness. You enter the amount to be withdrawn. It'll check whether the balance is there. If it is so, it will deduct the amount, then it will give you the cash, no matter how many times you give the same ATM, right? If you give the ATM card, it will give the same result. So those kind of algorithms are called as deterministic algorithms. Now there is one more type of algorithm called as non-deterministic algorithms. See here, it is a type, it is the one in which the output of every algorithm is not uniquely defined, hence the result could be random. sometimes what happens is when you give the inputs, okay, when you give the input to an algorithm, it will give you the output. Now, after some time, if you give the same input, okay, it will give you a different output. See, for example, in case of Turing machines, see, for example, there are two states, okay, Q0 and Q1. If I give this, okay, I am going to get the result as Q2. Sometimes what happens is if I give the same result Q0 and Q1, I might get the different result. So these kind of algorithms are called as non-deterministic algorithms. See, some examples that come under this is traveling salesman problem. See, finding the shortest path. So I can see the nodes will be fixed, right? If you remember a traveling salesman, okay, the nodes will be fixed, but you can reach the different places taking your own way. Suppose I can start at node A or I can start at node B. So no matter how many inputs I give, okay, the inputs will be the same, but because the inputs will be the same, the nodes will remain the same, right? But the output generated will be different, the path taken will be different. Okay, similarly for online shopping recommendation. Online shopping recommendation, that is, you have browsed for shoes. Next time it is going to show you some set of shoes related to the ones that you have seen. But next time, again, it will show you the recommendation, but a different set of shoes, right? Because a different recommendation. Your input was the same shoe, but every time it is not going to show you the same shoe. It will show you the different set of shoes. So this one is called as a non-deterministic algorithm. So you need the knowledge of these two in order to understand the NP-PNP problems. Okay. So there are two types of algorithm based on the output generated. That is the deterministic algorithm where the output is clearly defined, and there is non-deterministic algorithm in which the output will vary. Okay. With that knowledge, let us start the topic of P, NP and NP complete problem. In your syllabus, there is only P, NP and NP complete problem. So I'll be taking up that. See here, there are some algorithms, okay, who when you have these algorithms and you find the time complexity, the time complexity is of the type polynomial. See, it will be of the type. So let me thicken it. Wait. It will be of the type polynomial. That means it will be n, your input, to the power of some k. Okay. So this type of algorithm, see the definition you see, it is a class of decision problems that can be solved in polynomial time. Polynomial time means n to the power of. If there is an algorithm which can be solved in n to the power of k, those set of problems come under P. Class P means polynomial problems. Okay, these P stands for polynomial. See, examples are linear search, binary search, insertion sort, merge sort, etc. See, suppose I have a problem statement X and I apply the algorithm which is having the time complexity of n square. Okay. So these problems will come under P problem. So how do you define a class P problem? A type of problem in which the problem can be solved in polynomial time. These type of problems are called as class P problems, and the examples are given to you. Now, in your question paper also, in your model question paper, we have to explain these three types of problems with the relevant examples. See, I have taken this example, that is linear search. Okay, I've taken the example of linear search. So there will be three inputs here. So total number of elements, array, and the element to be found. So if the element that needs to be found X matches with the element in the array, then we return that position. Otherwise, we return -1. Okay. See here, the time complexity of the linear search is big O of n. See, because there's only one loop, and if you try to find the time complexity, it will be n itself. Okay. And no matter how many times you run, it will be the same. And because it is n, see, it will be like this, right? So Remember, polynomial means it should be of the type n to the power of k. So in case of linear search, it is n to the power of 1. So this linear search comes under the group of P problem. That is your polynomial problem. I hope you are understanding. The problem which can be solved in polynomial time means n to the power of k. Those algorithms which have this time complexity, and if you are using those type of algorithms to solve your problem, then your problem comes under P problem. Similarly, we have class NP problem. NP problem means these is a class of decision problems that can be solved by non-deterministic polynomial algorithm. See here, NP stands for non-deterministic polynomial. Okay. NP stands for non-deterministic polynomial problem. Non-deterministic polynomial. So, there, see, for P problem, the complexity was of the type n to the power of k. Here it will be of the power of the type 2 to the power of, okay, k. This type of problem. So suppose I have a problem X and I have an algorithm which is having the complexity of the type 2 to the power of k, then those problems which can be solved using these algorithms are called as, those come under NP problem. Okay. So what is the definition? It is a class of decision problems that can be solved by non-deterministic polynomial algorithms. Okay. See the means non-deterministic means what? We discussed already. That means for the same set of inputs, the output will look different. See the example that I have given. So the example that I've given is subset problem. See, why do you think subset problem comes under NP problem? See, when you're finding a subset problem means what? You have these values, okay, these elements, and you have to find the sum. Okay, you have to find which elements can be combined in order to find this sum. Why does it come under NP problem? See here. Here, we can easily find the subset which equals S as in this one, by adding the right elements, 2 and 3 in this case, and the time complexity is 0 of n, but 0, big O of n. But finding the right subset itself is hard. You remember that state space tree which we used? There were so many branches and there were so many combinations. You need to backtrack and all those things, right? So finding the right subset is hard, where we have to check all the possibilities. And possible sets comes under 2 to the power n combination, which is exponential time. Here, instead of the time going in polynomial, here the time will go in exponential. So these set of problems come under NP problem. That means non-deterministic polynomial problems. Okay. In case of polynomial, it is n to the power of, whereas in case of NP problem, it is 2 to the power of. Okay. Next comes NP complete problem. Imagine like this, okay, I have a problem, okay, which is extremely hard to solve. What I will do is, it's a NP problem, but it is extremely hard to solve. So instead of those problems are NP complete, what I will do is, I will take that problem and convert it into NP problem, and then find the solution for the NP problem. Those are called as NP complete problems. The problem by itself, if you want to solve, it will take a lot of time and it is very difficult. So what you do is you convert that problem into NP type of problem. See the explanation that is given. There is a problem D1. It is said to be polynomially reducible to a decision problem D2. So D1 can be reduced to D2. If there exists a function t, that transforms the instance of D1 to D2 such that T maps all the S instances of D1 and S instances of D2 and all no instances of D1 to no instances of D2. That means all the S instances in this case should match with this S instances, and all the no of this D1 should match with the D1 of no of D2. Okay. So that is what it means. So, and then you can compute that function using the polynomial time. See, there is a hard problem which cannot be solved. So what you do is you reduce it into a form which is of NP complete, not NP complete, NP, then you solve, which makes the problem easier to solve. Okay. So there is one more thing here. See this one. There is a problem D is said to be complete, NP complete if it belongs to the class NP and every problem of NP is polynomially reducible to P. See, all the NP problems can be, all the NP complete problems can be made it into NP problems and then it can be solved. Okay. So that is what. Now let us look at the example for NP complete problem. So before that, let us look at the, NP, a problem is called as NP complete if it satisfies the two conditions. One is it belongs to NP, that is a given solution can be verified into polynomial time, and it is NP hard. Every problem in NP can be reduced into a polynomial time and then it can be solved. The example that I've given here is traveling salesman. Why traveling salesman is NP complete? See here, it is in this non-deterministic polynomial. See, if the path is given, we can verify the total cost and check if it visits all the cities once in a polynomial time. But there is no known polynomial time algorithm to solve all the instances of TSP. So TSP comes under NP complete problem. Okay, so how do you relate this? First, you understand why there are two types of algorithms. For one for which the output is well defined, the other one in which the output is random for the same set of inputs. Based on that, we have problems which are of three types. One is P, NP and NP complete. So P stands for polynomial time, NP stands for non-deterministic polynomial time, and NP complete means non-deterministic polynomial complete problem. Okay. So if there is a problem that can be solved in the polynomial time, that is n to the power of k, then it comes under P problem. If there is a problem that can be solved in exponential time, that is 2 to the power of k, then it comes under NP problem. And if there is a problem that can be reduced into another instance of the problem, which becomes NP, and then you get the solution. So such problems will be considered as NP complete problem. Now there is one more, NP hard. Okay, it is not there in the syllabus, but let us see here. NP hard problem is a class of problems that are at least as hard as the hardest problem in NP. See, what does it mean? See here. Every problem in NP can be reduced into NP problem in polynomial time, and NP problems do not have to be in NP. Means their solution can be again found out in polynomial time. And the example I have given is knapsack problem. Knapsack problem you already know. So why is it NP hard? Because it is difficult to solve quickly when the number of items is large, isn't it? When the number of items is large, finding the knapsack is very difficult. Also, many other difficult problems can be changed into knapsack problem, which means it is at least as hard as them. Because of this, there is no fast method that is known to solve all the cases. So it is classified as NP hard. There is no specific solution for this. There are many solutions, but for all the instances when you want to solve one problem, one solution might not be feasible. So you try to use another one. That is also not feasible. So that comes under NP hard. Okay. So this is all about the four types of algorithms, four types of problems. Okay. That's all for this video. Thank you so much.